So here we have seen that the addition reaction of ethene. Ethene undergoes addition reaction. What we mean by addition reaction is you can add ethene to another ethene and it gives you what we call polyethene. Okay? Ethene and other unsaturated compounds undergo addition reactions, and addition reaction is the one in which a molecule adds to another unsaturated compound by breaking the double bond or a triple bond. Okay, so the addition reactions, you add one element that is unsaturated. So if you want to know that something is unsaturated, there are three things you need to test for. So when you add this, what happens is the breaking of that double bond and the triple bond. So that element you are using will go and attach itself to that broken double bond, and that is what happens. I had the same video here. I don't know if you can get it. Addition reaction of ethene. Ethene. Okay, if I look at it for now, let me show you that ethene is CH2, CH4, C2H4. When you add it to bromine, this is the first example. They are saying that ethene, when you bubble through bromine water, there is what we have bromine water and then bromine liquid. Those two things are different, and they are both used to check for the degree of saturation. If it is a double bond, then it's unsaturated. Now, if you want to know that something is unsaturated, we use bromine water or bromine liquid. At the end of the day, the bromine water is brown in color or reddish brown. Now, if you put it in an ethene, any element that has ethene, that brown color will disappear. Meaning, the bromine will go to the double bond where the double bond is and breaks off the double bond, and it becomes an alkane of this type here. Okay. So when the bromine reacts, there is a video here I wanted us to share, but if it is misbehaving also. Additional reactions of ethene. So the bromine goes and attaches itself to the double bond. So if the double bond breaks, ethene will attach itself to one carbon atom, the bromine will attach itself to one carbon atom, then the other one goes to the other carbon atom. So the name we get is this one. This one here. It is called 1, 2. Since there are two bromines, 1, 2 shows the position of the bromine branch. 1, 2, since there are two, you say di. Bromine is extracted from the name bromo, so it becomes 1, 2 dibromo ethane. Very good. That's the name we get from there. When I set my camera in the second session, we always have problems with the camera on Saturday, but Tuesday we shall always use our camera well. For now, let's just endure, but I will show you how that thing comes about. So that is when bromine water is added. What about another test for unsaturation is we use acidified potassium permanganate solution. That whatever is always purple in color. If you want to know that substance or the substance has unsaturated compound, when you put that manganese, potassium permanganate in the solution, it will always be decolorized. The color goes away. And then what will form is the or the OH. This is called the color will always be decolorized. I wanted to show that bromine shall also look at it. Then we also have hydrogenation, that is addition of hydrogen. When they say halogenation, you know halogens? You know halogens?
Yes, sir.
Which group do they belong to?
Group 7.
Group 7, very good. So if you add any halogen to a given compound, that thing is called halogenation. Now, if they say hydrogenation, you are adding hydrogen to a given compound. That's what we mean. So hydrogenation is addition of hydrogen to a substance. Now, if you add hydrogen to ethene, you will form ethane gas. So when alkenes react, any reaction they do, you must in position tell us that they form a given alkane. So if you add hydrogen to ethene, you'll be forming ethane. So when hydrogen and ethene, this is ethene, not ethane, mixture is passed over finely divided nickel catalyst, that is the catalyst they use, and heated to about 200 degrees Celsius, ethane is formed. The end product is ethane. So this one is ethene, not ethane. This one is ethene. So this sulfuric acid reaction is not so important to us. The most important ones are the first three. You check for the degree of saturation. You use bromine liquid or bromine water, and then bromine liquid and bromine water have the same color. So this is what happens to them. Then potassium permanganate, it is decolorized. This is the formation of this ethane 1,2-diol, OH. You're also going to look at that compound that has OH in mixed, when it's mixed, and that name gives us all the alcohols we have, all the ones some of us take, the alcohols. So this is the reactions undergone by that. The most important one is this one called polymerization. Polymerization. That's where our polymers come from. Ethene gas, that gas we prepare, can undergo, if it goes very high pressure, when the pressure is high, it becomes a liquid. The gas we have under conditions of high pressure can become a liquid. Now, when this liquid is strongly heated to about 200 degrees Celsius in the presence of oxygen catalyst, a waxy solid polythene is obtained. That is the way polythene comes. So when you go to those factories, all those machines are assembled to do that work. That when you have ethene gas, and when you want the gas to become a liquid, you must put it under high pressure. Now that pressure will compress those ethene molecules to form a liquid. Now when this liquid is strongly heated to a temperature of about 200 degrees Celsius in presence of little oxygen catalyst, a waxy solid, that waxy solid is our polythene, that white paper bag we use for carrying sugar, or the black one used for carrying items at home from the market. So the end product is this. So since there are many ethene gases, you get N-ethene. The number is not known, so they put N here always. So that N represents a certain number of ethene. So if there are like 20, the end product is polyethene. Polyethene. Poly means many ethenes. So poly, many ethenes. So the end product is C in brackets. This is C is in brackets, that same bracket. So you put CHN and then first bond CH2, CH2, and then all those are covered in brackets. I will show you how that ethene molecule looks like. But for now, let's just understand how it is formed. Okay? So under high pressure, ethene gas becomes a liquid. When that liquid is strongly heated at 200 degrees Celsius in the presence of the oxygen catalyst, little oxygen catalyst, a solid is formed. So the uses of ethene is one, manufacture of ethanol. We have seen how ethanol is put under concentrated sulfuric acid and heated. The end product is ethene. That reaction can undergo the same way. If you put If you add water to ethene, the end product is ethanol. So it is also used in ripening of fruits, like these fruits that are not ripe or they are not ripe. You can put them under that gas called ethene gas. After some few days, those fruits will be ripe. It is also used in the manufacture of plastics. We are going to look at synthetic polymers, those ones that are man-made. We shall see how that ethene gas. We have seen one way that it can be used to make polymers, synthetic polymers like polythene. Many ethene gas molecules combine to form a liquid. That liquid, when you heat, to give us the polythene. It is also used in the preparation of other solvents. We shall look at those solvents that we are made from ethene. Now, our main topic of discussion today is polymerization. Polymerization is the combination of many molecules of the same compound with relatively small molecular mass. Small molecular masses to form one big complex molecule with a large molecular mass. An example is ethene. Ethene, now we can look at ethene as a small molecule. Now, if they become many of the same compound like ethene molecules, many of them, when you heat them, you have seen that they condense to give us a liquid. When that liquid is heated at a certain temperature, they give us one complex molecule called polythene. And that is what is responsible for that reaction. Now, when these small molecules, the small molecules have a common name, and that name is called a monomer. So when they talk about monomers, these are the small molecules from which polymers are built. So in simple terms, somebody can define polymerization as a combination of many monomers with a relatively small molecular mass to form one complex molecule. How do you call that complex molecule? It is a polymer. So here they are saying the complex molecule with a large molecular mass formed by a combination of many molecules of relatively small molecules or small masses is called a polymer. Now, that complex is called a polymer. Then the smaller molecules to which that thing is built on is called a monomer. An example of a monomer is ethene, and the polymer it forms is polyethene. Most of the complex molecules formed have that name, poly. Everywhere where you see poly, you know that is a polymer, and it's a big molecule, complex molecule. Whenever you see a monomer, that is the simple substance to which it actually acts as a building block for a given polymer. An example, if you want a house, you use bricks. Now, those bricks, you can't bring one and say you are going to make a house. No, you bring as many as you can. Then from there, if the balance remains, they will say those ones are and don't have where to be put. But the main important thing is that brick or the block. When you put many of them in presence of maybe cement, you can get your building. So here they are saying monomers, the smaller ones, to form a polymer. There are many. We are going to look at a particular few, the ones that are used here. So before we jump onto another stage, the session is free and fair, and we want to understand this. Is there any questions so far? Do you have questions? Shelly?
Yes, teacher.
Is there any question?
No, but I wanted to see the formula for the part where you are talking of the formation of polyethylene.
The formation of polythene. We are going to see. Don't be scared. That one we are going
Okay,
to.
teacher.
Any other question? Somebody has sent. We don't have questions. Somebody has data problems. Where are these people? Coffee Lucy.
Yes,
What do you mean by polymerization, according to you? Hmm? Yeah. What do you mean by polymerization or something to be called a polymer? What does it mean? Hmm? Wendy. 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 Wendy.
yes, teacher.
What are the uses of ethene?
We think
Yes. Hmm?
for manufacturing.
For manufacturing what? Plastics. It is used in the manufacture of plastics. An example of that plastic is a polythene. That is good. So we are going to look at many monomers and what they give us. Additional polymerization we have seen. Somebody explain to us what is additional polymerization? Somebody is asking, ethene contains a double bond because it is derived from ENE and it is unsaturated ENE. When you get something with the name ANE, that is ethane or alkanes. Good. Somebody explain for us what we mean by additional polymerization. We looked at it even from here among the reactions undergone by ethene, additional reaction of ethene. So here somebody explain to us the type of polymerization. The first one is additional polymerization. When we talk about polymerization, we are talking about formation of a big complex or something big. So when they say additional polymerization, this is the combination of many small but unsaturated molecules. Here, when you talk about polymerization, it is only unsaturated molecules that take part in the formation of this. So unsaturated molecule to form a large complex without any other products. It is the only product formed. After those things combining, the only product formed is that polymer. So in this case, the polymer possesses the same empirical formula as the monomer. E.g., the formation of polythene is the monomer is ethene. Here, if there are many, the number is not known, they just indicate with N. And then the polymer formed is CH2 in brackets with those dashes, and then you put N. This one, don't be scared. The second session, we are going to look at it and see the correct equation for writing this. So that is one way, additional polymerization. Now, when you come to condensation polymerization, in the condensation polymerization, two different molecules. Those different molecules, maybe you can use ethene and any other molecule. But here, we use the same molecule, additional, we use the same molecule to form a complex one. So this is what they are meaning here. Two different molecules combine to form one large one with constant loss of a simple molecule like water. So water is produced at the end. Here, only a single product is formed. No any other compound is formed. Here, we see a complex molecule and other simple molecule like water, hydrogen chloride, etc. are formed. So the empirical formula of the monomer and the polymer are not the same. E.g., the formation of starch from glucose, and the formation of nylon. These are all organic compounds. You know nylon? An example of a nylon is this whatever they use for mending shoes, that small thread they use for mending shoes. It has that nylon bit of it. So that is what they form. Or starch, you get starch from glucose. So the body can get glucose from starch or starch from glucose. That's what happens there. So here there are types of polymers. Polymers can be broadly divided into two groups, namely natural polymers and synthetic polymers. So natural polymers, the one that occur naturally on Earth, include starch. The monomer is glucose. Proteins comes from the amino acids. Cellulose comes from glucose also. Glycogen is from glucose. Lipids, fats or oils, we get them from fatty acids or glycerols. Those glycerols, an example is the ghee we use at home, or how do you call this? Blue band. Those are some of the fats we use. Then natural rubber, that is isopropene, that is natural rubber, and it is used as, these are their uses. This glucose is a source of energy, starch, protein,